So the first question is compute the Jacobian of the following transformation. So as the input is the question is given x equal to v by u and y equal to u square minus 4v square. So what we need to do is we need to find the Jacobian of the given values. How to find the Jacobian values? Like Jacobian value is found by determinant of dou x by dou u, dou x by dou v, dou y by dou u, dou y by dou v. So we need to differentiate the given terms with respect to u and with respect to v, and we need to find the values, and we need to do we need to put the values in given determinant in a given determinant like given here this form. So x is given v by u. So first we need to find the determinant of x with respect to u. That is how will we do it? Dou by dou u of v by u, because x is given value, that is v by u. So we are differentiating with respect to u, so our answer will become minus v by u square. So just like as we did for that, we need to find the dou x by dou v. That means we need to differentiate the value x with respect to v also. So dou by dou v of v by u, how will the answer is 1 by u, because x, if determination of x with respect to x will become 1, x square will become 2x, like differentiation just like that, it become 1 by u. Same we did this for x, and next we need to do it for y also, like differentiating y with respect to u and differentiating y with respect to v. So the given equation is y is equal to u square minus 4v square. Okay, first dou by dou u of y will replace it, so dou by dou u of u square minus 4v square. So here v is constant, so it becomes 0. The only differentiating thing is u here, because we are differentiating with respect to u. So dou by dou u of u square minus 4v square become 2u. Okay, and that is equation equation 4. And next we'll differentiate y with respect to v also, that is dou y by dou v. So here answer become in this equation u become constant, so it becomes 0. And just we need to differentiate minus 4v square. After differentiating 4 minus 4v square with respect to v, it will become minus 8v. And now we have the four values like minus v by u square, and 1 by u, 2u, and minus 8v. We all take these values and we put the value in the formula as given, like j is equal to, and we'll find the determination like minus v by u square into minus 8v minus 1 by u into 2v. So we'll get at final answer is 8v square by u square minus 2. This is the Jacobian determinant of transformation from. Okay, and the next question is find the inverse of 3 cross 3 matrix. That matrix is given 1 minus 1 2 4 0 6 0 1 minus 1. So first of how we find the inverse, like a inverse. So what is a inverse? A inverse is nothing but when we multiply a and a inverse, the answer will be an 1 0 0 0 1 0 0 0 1, like a singular matrix. That is how, that is what the a into inverse of a values gives. So we need to find here, we need to find a inverse of given a. The a is given, the a is a given matrix here, we need to find the a inverse. How will we do it? That is, we have the formula. The formula is 1 by determinant of a into adjoint of a. So here we need to find the first of all we need to find the 1 by, like first we need to find determinant of a, and after we need to find adjoint of a. The first step will be like determination of like a determinant, what is its value. So like for this 1 minus 1 2 4 0 6 0 1 minus 1, for this determinant of a value becomes minus 2. How will we do it? Like if we take 1 in the c, like in the first row first element, that is 1, will multiply minus 1 into 6 minus 2 into 0. Like this we'll do for everything, plus minus plus, and we will get the determinant of a value. And after that will find the cofactor matrix. Cofactor matrix is nothing but this matrix, this given matrix, we need to find the value of this one. If we take this value of 1, we'll find the determinant of this matrix 0, 6, 1 and -1. We'll find this matrix answer and we'll replace it in 1, such like that. In the place of -1, like as we see here in -1, we'll find the determinant value of 4, 0, 6 and -1. We'll replace that in -1, such that we'll do it for everything, and we'll find the cofactor matrix. After finding cofactor, like as we got here, cofactor matrix is -6, 4, 4, 1, -1, -1, -6, 2, 4. This is the cofactor of A. After that, we'll take transpose of cofactor matrix, like the cofactors like which we got now. We'll take its uh, in like we'll transpose it. That is nothing but our rows will become columns, like C11, C12, C11, C12, C13 becomes C11, C21, C2, like C31. Like it will become, the rows will become columns. So after that, we got the adjoint of A. Now we need to substitute in the given equation. That is, we got the adjoint of A, we got the determinant of A. So we will submit, distribute it in here, and finally we'll get the answer. A inverse is equal to 3 minus 0.5, 3 minus 2, 0.5, 1 minus 2, 0.5. This is the A inverse. If we multiply A into A inverse, we'll get the answer 1, 0, 0, 0, 1, 0, 0, 0, 1. This is singular matrix. This is all about second question. And third question is about why is logistic regression termed as uh, regression and not classification? So first of all, logistic, like what is logistic regression? Like what is, first we'll learn about linear regression. What is linear regression? If we are having, like let's take an example. If we are having some five features, like five input data, like independent variables, and we have one feature that like dependent variable, we need to find the relation between these five independent variables and this one column dependent variables. So this is how linear regression work. Like it follows the y equal to mx plus c. That is line. For if we take a linear regression, y equal to mx plus c. This is a straight line. And if we take polynomial regression, the equation becomes changes. So the question is, why is logistic regression termed as regression, not classification? First of all, logistic regression, like linear regression, follows the it gives the value based on the previous data. So it finds the, like it, the data may be continuous, there is no breakage. But in logistic regression, there are only two types of output, that is 1 or 0, that is true or false, yes or no. Like it will give the probability. What will happen in logistic regression, it follows the linear regression formula. That is, linear regression is equal to y naught plus x1 y1 plus x2 y2 plus x3 y3, so on up to some error coefficient, which we can denote by e. Linear regression follows this. But in logistic regression also, this linear regression is used, and it is passed through a sigmoid function, that is 1 divided by 1 plus z e power minus z. So when we pass this linear regression in sigmoid function, it gives the value ranges from 0 to 1. That is that, like the value, the output value lies between 0 and 1. So it is just like saying true or false. Like we'll take the probability. If the given value is more than 0.5, then it is true, or 1, or I'm sorry, 1 or true. So if the given, the sigmoid function, after passing the linear regression in sigmoid function, if that value is less than 0.5, then it is 0. This is how logistic regression works. Thus, the logistic regression may be giving the input as only 0 or 1, true or false, yes or no, but it is following the linear regression formula. That's why logistic regression is termed as regression and not classification. This is the uh, everything about the first question. And the second question is, what is multicollinearity and how do you treat it, and when is it not a problem? First of all, what is multicollinearity? Manlo, like think as we are having some 20 features, like not 10. Let's not take 20. I am having 4 features. Like let's take an example of linear regression only. If I'm having an input variables like independent variables, I'm having four features, and in output variable, that is dependent variable, I have like that is one column. So what I need to do here, I need to find the relation between these four input features and one output features. Like how features are these four features making this output. How it's like which one need to be focused more. Like which feature I need to focus more. So this is how linear regression works. And now this two like x1 let's name x1 x2 x3 x4. These are my four features. Let's assume x1 and x3 are having collinearity. That is, if my x1 increases, my x3 is also increasing. If my x1 is decreasing, my x3 is also decreasing. If my x1 is 0, then my x3 is also 0. What does it imply? That is, it directly says there is a collinearity between my x1 and x3. So this is not actually big problem. Like we have many steps to avoid it. Like if that really these two data like x1 and x3 are implying the same like they're both are almost similar feature, then it's better to remove the one of the feature. So anyways, we don't have any data loss. So by doing this, our model prediction is good. What will happen if we didn't remove any of the one, or if we didn't collide both and like make a separate column? What will happen if we didn't do it? Our model goes for all four features and give the equal importance for everything. So it while it giving the importance for one of the feature, it may do some mistakes. Like machines are not the machines are not like 100% true, or we can't rely on completely on that machine. So removing this like same collinearity, this having like x1 and x3 like that, whichever which sometimes if they are having collinearity, it's better to remove one of the feature, or we should combine and make this another feature like x5. So it's better if we do it. Okay. And we are also having ridge regression and lasso regression, where multicollinearity sometimes may happen. So we are having ridge regression and lasso regression. In L2, that is ridge regression can reduce the coefficient size and handle multicollinearity, and in lasso regression it can eliminate some features entirely. This is how we can make use of lasso regression and ridge regression. They are just the updated version of linear regression. That's it. This is all about like whenever is a multicollinearity, not it's a big problem. Actually, the goal is prediction, not interpretation. Exactly. So we can use this regression and laceration. We can make the uh, answer. So next comes the briefly explain hyperparameter optimization and strategies and optimizations performance. Firstly, there are two types: parameters and hyperparameters. Parameters are nothing but our model learns the sum of the values by itself. That is called parameters. And hyperparameter is nothing but for working of the model will give some inputs for the model, so that it should you have to work like this. That is called hyperparameter. So like we cannot change the parameter values, because the our machine learning model learns that those values by itself. But we can change the hyperparameter values, and we can make our model prediction very good and fantastic. So what are hyperparameters? Like if I want to give for example for hyperparameter is uh, there are lots of hyperparameters, example and random search, and for example clustering in clustering analysis. And we want the like in k means clustering, we want the k value. So we need to give it actually like how many clusters we want. It may be 4, it may be 5, 6, 7, 8, depending on our problem statement. We need to give the clustering k value, and finally we'll find that k value through like Silhouette scores and elbow method. But we are giving the value to the model, like make this much clusters. That is perfect example for hyperparameter. So hyperparameter tuning is one of the most and important thing which we do in machine learning. And this is all about hyperparameter. Like third question.